Back to EMC 645, System Design and Operations. The title of this session is Communication Center Operations. In this session, I want to briefly review the technical communication elements. I want to briefly take a look at center design and operations, call taking and medical priority dispatch, briefly look at emergency medical dispatchers, quality programs, and look at what a system approach entails to a communication center operations. While many of the things that we discuss in this lecture should be reviewed as they're covered in basic EMT classes, I want to briefly talk about some of the technical components just to make sure that we're all talking the same language. So this brief review will go pretty quick and it'll just briefly look at some of these components. In your particular operations centers, if you're dealing with various type of communications, you definitely will want to look at more in-depth information on all of these technical components. But some of the primary system elements that's important to think about when thinking about communication center operations are the ones listed here. The 911 access point may be part of your communication center operation, or it may be adjacent to your operation. Quite often this is referred to as a PSAP, a primary system access point. The second component I have listed is communication center staff. This includes call takers and dispatchers, which both may be trained as emergency medical dispatchers. A third element of communications is field receiving units. This may include pagers, radios, mobile data terminals, printers, field communication centers, and disaster operation communication centers. All of these things would be classified as field receiving unit components, as would the next list be considered as field transmitting unit components. This might include mobile radios, portable radios, again, mobile data terminals, cellular phones, field communication centers. And then the last thing I have listed on the list is AVLs, or automatic vehicle locators. Well, we've come a long way in communication centers. You see here a picture of some early dispatch consoles. And if you look at current consoles, quite often they're divided into two components. Quite often we look at the call taker position within a communication center, and then we look at the dispatch console. And most progressive communication centers actually have a split between the two, and instead of duplicating the role of a single individual, they utilize two specifically tasked individuals to operate in these two positions. This actually increases exponentially the efficiency of the operation center. Now, some smaller communication centers, it may not be possible to delineate these two tasks into two separate jobs. Even in the situation where a system has individuals trained for these two primary tasks, most of the time they're cross-trained so that they can cross between the two jobs and fill the different positions at different times of the day based on need. Well, a couple other aspects of communication center terminology that's very important to look at is the anti-alley, especially in emergency enhanced or E911 communication centers. One of the things that happens is when a call is received, it actually dumps onto the screen what's considered an anti-alley. The anti being the automatic number identification that identifies the number the person's calling from, and the alley being the automatic address identification. These two components have greatly enhanced the ability to get resources to individuals in need more quickly, as this information can be immediately confirmed and passed to the dispatcher, who can go ahead and start a unit headed in the direction of the information that shows up from the E911 anti-alley data that's seen here on the screen. Well, mobile communication centers have come a long way also. Quite often you see these in larger urban environments or in areas where there's some extended communication need, such as forest fire operations or wildlife fire operations. Wildfire operations is a key area that you see mobile communication centers used. Another aspect that's sometimes forgotten about is the Emergency Operations Center. The Emergency Operations Center becomes key in disaster type situations or situations that are going to progress over a number of days, that's going to entail specific communications. The advantage of an Emergency Operations Center is that you actually are able to put individuals representing the various organizations at a table together or in close proximity such that it's very easy for them to communicate between locations. Now, over time, we're quickly seeing a move towards people wanting to figure out how to have cross-agency communications, multi-agency communications within the context of two-way radio communications. Unlike some, I'm a little biased that may not be the best operation. The key aspect of a communication center, emergency operations center that you see here, is that it tries to utilize the incident command system, whereby individuals representing various components conduct the information or conduct the business that needs to take place in each individual respect. Let me give you an example. So in this scenario, if we have fire, rescue, and EMS and law enforcement in the same room, there's really no need for the fire organization to be able to communicate on the law enforcement frequencies. Instead, a better approach may be to actually have key individuals, administrative individuals from the various organizations together. They can discuss the key components, and then the respective communication can take place on the frequencies of those given organizations. Now, where this has really come into question was with 9/11 in New York City. During the attacks on the World Trade Center, there was a lack of ability to communicate between various agencies that were responding to that location. Again, one of the concerns with that type of communication system where there's readily available communication that can talk across frequencies or the ability to actually match together various frequencies is that very quickly in a situation such as 9/11, you could have a frequency completely overwhelmed with the number of people that are involved on that frequency, hence decreasing the ability to communicate. So I think there's still a long way to go in figuring out from a disaster perspective what is the best approach to the various communication system elements. And luckily we have numerous groups in operation across the country that are trying to address some of these issues now. From the radio system perspective, again, just a quick review of some of the terminology. We can talk about frequencies versus bands. We can talk about simplistic or simplex versus duplex systems, repeater systems, very high frequency or VHF frequencies, UHF or ultra high frequencies. More commonly now we're beginning to see 800 megahertz and 900 megahertz radio systems that are used in EMS. So we'll briefly talk about a few of these radio systems. Again, in the past, we primarily used either very high frequency or even low frequency radio, low band frequency radio waves, simply because there was an ability to transmit over a longer distance. Even here in our state of North Carolina, we've seen the use of low frequency or low band radio frequencies by the State Highway Patrol for years, simply because it allowed them to transmit over really long distances with very few repeater stations in between. But today, we're starting to see a lot of changes. Today, with the advent of things like medical priority dispatch, pre-arrival instructions. From a radio system perspective, we're seeing things like mobile data terminals and laptops and PCs in our vehicles. There's a need for a different frequency and different bands than historically were used. Mobile data terminals don't operate well over this really low frequency, or can operate under these really low frequency communication systems. So we started to see a transition over the last several years to ultra high frequency communications, and then ultimately, very high frequency communications to ultimately to ultra high frequency communications. In the future, as we see systems grow, we'll probably have more repeater stations, and we'll see more types of data actually transmitted between locations. Had the opportunity several years ago, actually probably more than 10 years ago now, to be involved in a pilot project whereby the idea was to actually create the ability to transmit patient information directly from an ambulance or a helicopter to an awaiting trauma center. The idea was to give the physician the ability to assess the patient to some degree prior to the patient actually arriving at the trauma center. Well, there's two aspects to this type of system. While the technology was very interesting, it made it very complex in the sense that it required real-time documentation of some of the data, which quite often wasn't done prior to that time. Quite often we would write vital signs, etc., down on a piece of paper or on a piece of tape to be recorded later in the course of providing care. And it also meant that there was less of a need to have as highly of trained individual taking care of the patient. So as we see communications change over the next several years, it'll also dictate to some extent the level of competency we need among individuals. And it could go either way. It could actually increase the level of education and training needed among emergency medical service personnel, or it could decrease the level of training needed among emergency medical service personnel. So this will be very interesting to watch as we move into the future. If we think about communication systems, there's really 5 phases to EMS communications. There's the occurrence of the event, detection of need for emergency services, notification and emergency response, EMS system arrival, treatment, preparation for transport, and then preparation for the next emergency response. So you can see there's several aspects or several roles involved. And if you think about the roles of communication and you kind of lay it out in an algorithmic format as you see here, there's a lot of need for cross communications between organizations. And it really varies between organizations. In some organizations, there's a simple request, as you see here in the center, request for help to the communication center. The communication center notifies the EMS crew. The EMS crew responds to the patient. Information from the patient can actually flow back up to the communication center if there's a need to do that. And there's the ability of the EMS crew to communicate to the communication center if need be for additional information, etc. A couple extra errors that I actually added in is that also, in addition to the EMS crew being able to talk to medical direction and to talk to hospital staff, there's also the ability for the hospital staff. So if we look at a flow, algorithmic flow of communications that takes place, you can see here we have a request for help to the communication center. The communication center conveys that message to the EMS crew, who responds to the patient. So there's an interaction then between the EMS crew and the patient. There may be a continued interaction, and there usually is, between the EMS crew and the communication center. Then there's a communication that takes place between the hospital staff and the EMS crew. If required in a particular patient situation, there may be the necessity for a communication between the EMS crew and the medical director. or medical direction. But there's also a couple other lines that I've actually added in here that I think are very important. Sometimes there's communication between the medical direction and hospital staff. That in particular happens when the two aren't the same. In some locales, the communication, the medical direction is actually provided by an external source. And that source will have to communicate to a particular hospital that the patient's being transported to. That can take place back through the communication center, as you see here, or it may take place directly to the hospital. So there's continued interaction, multiple interactions that take place. And in these interactions, there's a lot of ways communication can break down. And also there's a lot of need for technical capabilities in creating these communications. If you look at some really large EMS systems that have really progressive communication systems, some have microwave links between all the hospitals in a community that allows continuous communication from a communication center, maybe that provides medical direction, and to hospitals on a continuous basis. So these can be very complex systems. So if we think about the basic mode of communication, that's important because when we're talking about technical communication, it's important to think about the model of communication and what's actually transpiring. As you see here, we have an idea. The idea is encoded in some way and sent through some medium to a receiver, where it's decoded, and then feedback takes place back to the sender. So we have the idea, it's encoded, it's transmitted through some medium, it's decoded, and then feedback should be received from the receiver. There's a lot of terminology that goes along with communication systems. There's kilohertz, megahertz, microwave. As I mentioned earlier, the microwave links. Something a little bit newer is mobile data terminals that are actually placed in units. And an organization, when they're thinking about something like mobile data terminals, have to think about the feasibility of it. What are the benefits? What does it add to the system? Mobile relay stations, multiplex, NiCad batteries. As a side note, one of our interviews earlier, one of the interviews that you had with Terrence from Pinellas County, Florida, post the interview, we were actually having a follow-up conversation, and he was saying one of the largest problems they're having today is actually with battery life. In the last several years, four years or so, they've acquired a lot of new technical equipment. And if you think about new technical equipment is quite often battery powered. Well, they're at the stage now that a lot of those batteries are beginning to wear out. And as they wear out, there's a tremendous expense in replacing those batteries. So they're beginning to look at innovative ways to actually support battery life. And one of the things they're considering right now and actually doing some pilots around is actually solar powered battery chargers in ambulances. So they're placing those in effect. So hopefully in a later interview we can revisit Pinellas and see how that's actually working for them. There's paging equipment. Range is an issue. Simply when we think about range, the distance we're able to transmit with different types of radios. Special emergency radio services, simplex, squelch, telemetry, tone, transceiver, trunking systems, ultra high frequency, very high frequencies, watt. All of these are terminologies that it would be important if you're managing a communication center to have a good understanding of this comprehensive list. Well, one of the newest things to arrive in the EMS communications over the last several years is cellular telephones, and they're being used more and more. There's some good things about cellular telephones, and there's some things that aren't so good. Quite often, these may be used as an alternative to a dedicated EMS communication system. Specifically, we see them used quite often in communication between field crews and the hospital, or field crews and medical direction. The advantages: they're convenient, they're widely available, they're cheap. in terms of the equipment initially. The initial capital outlay is often pretty economical, and they can be fairly economical to operate over time when compared to the cost of maintaining other types of radio systems. The disadvantages, the strength, they need multiple towers in the event of a disaster where towers go down. Cellular telephones are virtually useless, so you could wipe out the entire communication system very quickly if you're only using cellular telephones. And there's also a queuing issue where signals are actually queued. So in the event that you've got an emergency call and you need to get through quickly, you may find that the tower is overloaded and not able to handle your call. Now, there are some solutions. Many paging systems are beginning to give priority to certain type phones, and I'm sure there's probably the same ability to give queuing priority to emergency services. Well, there's multiple digital modes of communication. We've already mentioned some. There's digital phones, telemetry, fax transmissions. Signals are used in wireless phones, paging, alerting systems. All of these are digital forms of communication. Some of these we're starting to see drift away. Telemetry was very big in the 70s and early 80s with the transmission of EKG signals to a hospital for interpretation. Doug Weaver, a cardiologist who had an interest in emergency medicine, did some studies, I believe it was in the early 80s, around the use of telemetry and found that it was not very economical to actually use telemetry systems. It was much more economical and more reliable to actually teach paramedics and train paramedics and educate paramedics to understanding and being able to interpret 12 or 2-lead EKGs at that time. We didn't learn a whole lot from that experience because when 12-lead EKGs came along, we spent a lot of time thinking about telemetry again and thinking about the ability to fax transmit EKGs to different places. And once again, we have seen the same type thing happen. Over time, more and more systems are moving away from telemetry, allowing paramedics to make the interpretation. And then once a patient arrives at a facility, then the hard copy of the EKG can be passed along to whoever may need to see that. So again, that's telemetry and facsimile. And here again, if you think about telemetry and facsimile, they're just transmitting electric signals which are converted to auto tones and then converted back. Now, from a facsimile perspective, a fax perspective, there is one big advantage. If you're faxing legal documents, it can be considered a legal document. In my work as a consultant, quite often we have individuals that would rather send fax transmissions than emails because they feel that it's more of a legally bounding document. So usually when we're doing work with contracts, we have individuals that want to fax information to us as opposed to emailing it. The disadvantages, the simple one for me is that it's very difficult to take and turn that back into an electronic format that's more mobile. It can be done very easily by scanning it back in and making a PDF of it, or using optical character recognition software and scanning it in so that it becomes a Word document. But there again, it's that added time and effort and expense of actually turning it back into an electronic document. We're seeing computers used more and more in EMS. The advantage is email is readily accessible to everybody. The cost is decreasing in using computers. Computer data capacities continue to grow, so it makes it easy to store large amounts of information. If you think about early computers, it would have been very difficult to even store a comprehensive set of pre-hospital medical protocols. Today, it takes up a very limited space, and you could probably store all of the pre-hospital medical protocols for all of the systems in the United States in a laptop configuration with an 80 gig hard drive or something like that today. And we're seeing those grow rapidly. Lenovo, one of the computer makers who actually bought out IBM's ThinkPad business, is actually working on terabyte hard drives for laptops. And you think about that capacity. That's a huge capacity. That's a capacity large enough. Well, actually, most of the computers we have today have capacities large enough to actually hold all of the original computerization that ran the space shuttle. So we have very powerful systems. The disadvantages, they need power. We have to look for power sources. So again, we're either back to the issue about batteries that I mentioned earlier, or we're looking for a plug continuously to plug in. Another big disadvantage is that it's a security issue to have tons of information located in one place. If people do use computer systems, it's important that with computer systems that you have frequent backups of data. And it's also important that you think about the security systems of how people access a computer. We're seeing more and more computers, specifically laptops, with fingerprint recognition software. So you can actually use fingerprints to access the data in a computer, which is an added security. But it's important to have some type of security backup system to make sure that people that shouldn't access data won't be able to do that. And that's even more of a concern with the HIPAA regulations today. If we think about the technical aspects, again, I know this is review for you, but a simplex system, you have a transmitter that transmits to a receiver in one direction. So A can talk to B, or B can talk to A, but they can't talk at the same time. Quite often, the advantage of these type radio systems is that they're either a low frequency, ultra low frequency, or ultra high frequency, which gives them a whole lot longer range than UHF or ultra high frequency radios. The disadvantage, you're unable to interrupt. Again, thinking back historically in EMS, this was a huge issue when we first started putting ALS in the field, because physicians wanted the ability to immediately interrupt the paramedic while they're talking on the radio to give them instructions. Another safety precaution of having a duplex system where either A or B could talk at the same time to each other, much like a telephone system, is that you don't run the risk of one radio getting accidentally keyed up and actually engaging and preventing the other person from talking. And again, this was a huge concern with medical direction. They wanted to be able to communicate orders in a very rapid way because they felt that there was the need to be able to be on top of things and tell paramedics exactly what to do on a case-by-case basis. And I don't think we ever saw that in full strength here on the East Coast. But on the West Coast, it was really a huge issue. Kind of the way the systems worked on the West Coast was that, specifically in Los Angeles County, in that area, 2 paramedics would respond to a call. One paramedic was actually designated as the radio operator. As soon as they arrived at the scene and they had ALS capability, their task was to get the radio set up with the base hospital so that they could communicate continuously while providing care for that patient on the scene. So you can see with that thought process, there would be a real bias towards duplex radio systems. So that's what we saw with the advent of app cores and those similar type radios that could send telemetry and also could have two-way communications. Multiplex systems can send not only voice in 2 directions, but also can send things like EKGs. If we think about trunking systems just operate in a very economical way. the idea of a trunking system is to create an economy or an economical way of communicating. You may have, as you see here, 5 channels. When somebody keys up the radio to talk, individual crew keys up the radio to talk, it'll actually transmit or engage the central controller. The central controller will determine exactly what frequency their transmission will be transmitted in on. The same way when it's transmitted out, the central controller will look for an open frequency and send it back out. While this doesn't seem that economical looking at it as we are here, if you think about an organization that has lots of radio traffic, you can really decrease the number of frequencies that are needed if you have the central controller kind of working as a queuing network to figure out who will talk on which frequency. So the reality is, if you were trying to listen to these frequencies, say for instance on a scanning radio, a scanner, you would have a difficult time doing that because I may talk to you on channel 1, and when you talk back to me, you may talk back to me on channel 2, and the next time I talk to you, I may talk and transmit on channel 5. So you can see it's a very complex system, but again, the idea is to decrease the number of frequencies that are actually needed for transmission. If you think about dispatch systems, there's several things that are worth talking about. 911 is become widely known now and is becoming universal throughout the United States. Enhanced 911 centers, or E911, as we mentioned earlier, the advantages there is actually getting the anti-alley information. If you recall, that was the number of the caller and also the location of the caller automatically when it comes into the communication center. And then computer-aided dispatch is actually having that computer console that can aid in dispatching in some way. Now, these vary in complexity. If you think back to our deployment lectures, we talked about static deployment and we talked about dynamic deployment. There are very specific systems that support these two types of deployment. The benefits of a dynamic type console, something similar to the products that are released by Zoll or by Tritech Data, these products will actually support dynamic and static deployment systems. However, if you think about some of the static type consoles, they actually won't support dynamic. So let me try to give you a quick example. Say for instance you take your community and you zone it out into 5 different zones. A static oriented computer-aided dispatch system will look at it and say, if zone 1 is supplied by station 2, then when station 2 is out on a call, we automatically look to the next closest station, which for instance in this scenario may be station 3. If station 3 is out on a call, then we'll go to the next station. Well, the problem is that we may have a unit from station 5 at station 3 if we have a dynamic deployment system, and there's no way for our static system to actually know that. So unless we're continuously changing unit numbers, and we call the old truck 5, ambulance 5, now ambulance 3, so that the console knows which unit is in station 3, then we have a difficult time when we try to dispatch calls. So from an EMS perspective, the newer systems that have the capability of doing dynamic reallocation and supporting that are very beneficial in supporting not only static deployment but dynamic deployment also. Another thing that helps with that also is automatic vehicle locators and global positioning units. These tell dispatch units the closest unit by air miles. A unit can be dispatched from the scene, dispatched to the emergency scene that is the closest based on some analysis of all of the available units in a system by looking at the global position, if you will, of particular units. Another advantage to these that you see listed at the bottom is that it also has the ability to track travel times. Some of the systems actually take repeated measures. There's actually API connections that can be enacted with the satellites from, I believe it's Yahoo, and Google probably has it also now, where you can actually get a download of the geographical position of a unit as it travels every 20 seconds or every 30 seconds, so that you can actually watch the route of the call. The other benefit of that is that you can actually take those measurements, and because you have a context of time and a context of location, you can actually calculate the average travel time and the overall total travel time to a particular call based on those repeated measures. So it can be very beneficial in helping you determine things like travel time within an area. When you listen to the interview with Jeff Goldberg and he talked about computer simulation modeling, one of the variables that has to be included is travel time in particular geographical areas. So if you're looking at very inner city in a very populated place, say New York City, the travel time is going to be very slow. So traveling even a couple blocks may take a good bit of time. Where if you're out in a rural area, then traveling a mile may only take a minute or a couple minutes. So you need to be able to integrate that information into the computer simulation models. And one of the ways to do that, again, is to download some of that or create a download from the API connections to something like Google or Yahoo, or to have some type of system that measures internally these times. The other way of doing that is some of the systems that have black boxes on the units actually can measure impedance times and can capture that amount of travel time and how fast the unit was moving during the course of a response, and that information can actually be calculated and downloaded back into a system and used as travel time calculations also. So there's multiple ways to get at that information. Another aspect that EMS administrators should have an awareness of is the regulations, or FCC regulations. And these are changing somewhat as more and more frequencies are being opened up for emergency communications and things are being moved around. So you should just keep an eye on what these current rules are, and remember that you are required to have license. So as part of your job as an EMS administrator, that may be part of your task, is to ensure that the appropriate licensures are in place. If we think about dispatch, the function is simply to receive and process calls for emergency assistance and to select the appropriate course of action for each call. This may include sending various types of units on a call, and it may also require something such as providing pre-arrival instructions that you see here at the bottom of the list. Well, here's a set of questions that it's worth thinking about when you're thinking about setting up a communication center and thinking about its layout. And I think this is very important for most EMS administrators and leaders, because many are in the position where they have a desire to be more involved in the communication aspect, which traditionally has been run by law enforcement or fire organizations in their municipalities. And as they move into the direction of taking more responsibility for this, I should think about the EMS dispatch component and realize that it is very different than fire and law enforcement dispatch. And here are some of the things I should take into consideration. The first thing, of course, is do you control the center, as we just mentioned. The second thing is it part of your EMS system? If you should remember that if you're providing pre-arrival instructions, then in many locations in the country it is actually considered part of the system. And as such, there should be protocols, there should be medical direction, there should be quality improvement efforts that integrate that system into everything else that's happening in your system. Then you have to think about how many call-taking stations are needed. You have to think about how many are call-taking and dispatching versus supervisory or standby. You have to think about how are the stations arranged and why are they arranged that way. Do you record incoming calls? For the most part, everyone records incoming calls, just simply to have a legal record of what transpires during the course of an incoming call. And then how long will you maintain these recordings of the calls? Another function that you may provide is medical party dispatch. Here you can actually see Paul Pepe, who is the medical director in Dallas, Texas now, and the chair of emergency medicine at the hospital there in Dallas, Texas. And historically, he was the medical director of Houston Fire Department and Houston's EMS system, and prior to that in Seattle. And Dr. Pepe actually spent a tremendous amount of time working with the medical party dispatch system in Houston and now in Dallas. And the context was he felt that medical direction should be applied to the call-taking process and the pre-arrival instruction process just like it should be the paramedics providing care in the field. So he actually spent time working with the communicators in mentoring them in the appropriate use of medical party dispatch systems. So some questions you might want to ask about your medical party dispatch. What version of MPDS do you use and have licensed? Do you use ProQA or Aqua, which are tools that are provided by the medical party dispatch folks to actually audit calls, to look at the appropriate handling of calls, to determine if the appropriate call designation was presumptive run classification was used? Do you use cards or are your protocols computerized? Hopefully most people are moving towards computerization of cards. It makes it much easier to transition to the new cards. Do you have medical oversight? What are the requirements for your medical oversight? As an EMS administrator, that may be part of your responsibility is to actually figure out what role a medical director will play in overseeing your communication center from a clinical perspective. And are your clinical field protocols and pre-arrival instructions synchronized? Sometimes we find that that's not the case. You may have a communication center that has one medical direction or one medical director who decides to use medical party dispatch. It's implemented, but it doesn't coincide with the field protocols that are used. So it's important that there be one medical direction focus or medical community that the medical community is agreed upon in a geographical area to make sure that there's synchronization between those protocols. If we think about the Academy of Emergency Medical Dispatch, they have a certification process. And here are some questions that are important to consider as part of the certification process. Are your personnel certified as emergency medical dispatchers? Do you provide continuing education for your EMDs? Is the continuing education provided by a certified emergency dispatch quality certified trainer? Do the emergency medical dispatchers feel that they are part of your system? That's a very important point. Do they feel like they can actually come to medical direction or come to you as an EMS administrator or leader and let you know that there's issues, that field care that they're observing is inappropriate in some way, or maybe they simply just have questions about why certain things are done. Is there an avenue for them to get those questions answered? Do you have a dispatch review committee and a dispatch steering committee? Do you maintain records of their meetings and efforts? Accreditation requires 3 meetings every 6 months to be compliant with the requirements of the Academy. Do you monitor compliance of presumptive run classifications? It's very important. and it's very interesting to see the difference between different organizations. I've worked with some organizations that have compliance rates in the 25% range. That means that out of every 4 calls that come in, 3 they misclassify. There are real issues with that, especially in systems that may want to utilize some tiered type response, as we talked about in some of the earlier sessions, where they have both BLS and ALS units, and they're making a decision about whether to send BLS or ALS based on their run classification. So compliance is very important to monitor. Are all your efforts, your quality assurance efforts, or do you actually try to improve things also? You see a kind of a representation of that at the bottom with a scale. If you think about the difference between quality assurance and quality improvement, they're completely on opposite ends of the scale, and they tip against each other. Quality assurance is really about keeping things the same, making sure there's consistency, making sure routines are locked in place, making sure that you control the way things are done. On the opposite end is quality improvement, and quality improvement is not as much of an auditing process as it is a research process. It's about looking at the way things are done, evaluating the way things are done, asking the question, is there a way that we can do things better? So it's somewhat of a conflict to have individuals and organizations that work as quality assurance and quality improvement officers because there are 2 competing jobs. So if an individual's in that position, they actually find themselves at a constant struggle trying to figure out which piece they should do more of. Should I measure more for consistency, or should I look for new and improved ways of doing things? Well, it's interesting if you think about kind of the industry around quality and what we know about it. We've actually seen a transition from quality assurance more towards quality improvement. If you look at some of the cutting edge methodologies, we do a lot of Six Sigma education, and with Six Sigma the concept is, instead of trying to get everybody to do it exactly the same, let's collect data, let's evaluate it quickly, let's understand the process, and then let's implement some new process to make it better. So it's almost an action research cycle where we do something, we try to make it better, we reevaluate it, and we do that again. So it's a continuous process, a continuous loop of trying to make it better day by day. How do you determine how many records to sample? Do you have a repeatable process? Do you do it the same way each time? Is it something that can be documented? And then finally, how do you evaluate customer satisfaction with the process? If you look at performance levels that are required by the Academy, at least the 3 months preceding the application, 95% case entry, you should have 90% of key questions, you should be at 90% for pre-dispatch instructions, 95% for pre-arrival instructions, 95% for chief complaint accuracy, 90% for final coding accuracy, and 90% for total compliance score. So you see, it requires a high level of quality to actually be certified as an accredited emergency medical dispatch center. As we mentioned earlier, it's important to coordinate all of these efforts, though, with field operations. So the question is, do you coordinate efforts between the field and communication operations? Do you update communication staff when changes are made in the field? On the other side of the coin, do you update field staff when changes are made in communications? It's important for both to be able to understand the other's perspective and to work together. If you're going to try to have them work together in unison, it's important that they understand each other's roles and responsibilities. And then the last thing I wanted to mention is that with medical priority dispatch, quite often you'll have local response assignments. The question becomes here, have you gone through each of the medical priority dispatch determinant codes and decided how and what resources will be sent to each type of determinant code? Now there's some baseline recommendations that are part of the medical priority dispatch system. However, most communities find a need to tailor that to some extent to their local system design. So it's very important to go through each code and ask that question. Then there's the question, has these decisions been reviewed and approved by the local medical community and medical direction? And then again, is this process repeatable? When is it repeated? How often do you look at it? And what leads to repeating the process? Do you maintain data on all 300 determinants or not? So you have to think about these sorts of questions and determine how often you're going to come back to it, just like you do with medical protocols. Well, in conclusion, we've gone through some of the things that are important to the operation of an EMS communication center. We've talked about some of the things related to accreditation of a communication center, and we've talked about a few of the things that may be required to adopt medical priority dispatch and communication center operations to meet local needs.